You can't beat the feeling of using an original retro computer, but 40-year-old electronics can be hard to maintain. So why not build your own Raspberry Pi powered Replica ZX Spectrum? Let me show you how. Hi and welcome to Bytes and Bits. In one of my last videos, we used a bare metal emulator to turn a Raspberry Pi into a ZX Spectrum, and that was using an emulator called ZXBaremulator. Now that allowed us to boot our Raspberry Pi direct into the actual emulator so that we had a ZX Spectrum sitting in front of us in only a couple of seconds. And I said at the time that that was ideal for use as building a replica ZX Spectrum. So I have here a ZX Spectrum Plus case and keyboard, so there's no motherboard inside this one. So let's use this video to show you how we can turn this into a fully working replica ZX Spectrum. Now before we get started, you need to get a Raspberry Pi set up with the ZXBaremulator. So as I said, I have covered that in a previous video, so I'll put a link to that up in the top corner here, and also that will be in the description down below. But basically, follow through that video, and in a very short time you will have your Raspberry Pi all set up and ready to emulate a ZX Spectrum. Now, to build this project, you're also going to need an original ZX Spectrum case and keyboard. Now, we don't need to have a working motherboard or any other power supplies or add-ons, so have a look on eBay, which is probably your best bet, and see if you can pick up a non-working computer. Now, the original 16 and 48K models, the Spectrum Plus and the 128K machines, these will all work great for this project. The Plus 2 and Plus 3 actually use a different keyboard matrix, so the ZXBaremulator won't actually be able to correctly scan these models, so do avoid those. Now when you are buying your computer, do try and make sure that the keyboard is in good condition, otherwise you're going to need to replace some of the parts, which can of course push the cost up. Now if you do find you need some parts, there are a number of suppliers that you can use, and I'll put some links to those in the description down below. Now some of these part suppliers will also sell refurbished cases and keyboards so that you can make sure that they are in working condition. Or some even sell brand new parts, and enough so that you could actually build up a brand new system from scratch. So do have a look around to see what route suits you best. Now, whilst we're on the topic of hardware, we do need to have a think about what Raspberry Pi we're going to use. So in the installation video, I used a Raspberry Pi 02W. And in my opinion, this is actually the best option for embedding a Raspberry Pi into the actual case. But I'm actually going to propose two options for you now on how you mount your board. Now the circuit we'll build will basically mount the Raspberry Pi so that it pokes out through the main expansion slot at the back of the Spectrum case. Now this is why I prefer to use the Pi Zero, as all of its ports, which are the HDMI, the power and the USB, these are all mounted along one edge of the board, and they're nicely spaced out so that they will fit almost perfectly into that available slot. Now, of course, mounting your Raspberry Pi in the case does mean that you need to dedicate that Raspberry Pi to this project. So I'm going to propose a second option, and that is to mount a 40-way IDC connector in the expansion slot. And that then allows you to run a ribbon cable out to the GPIO connector on a Raspberry Pi, which you're going to mount elsewhere. Now we can organise the circuit so that all the connections to the original hardware are going to be made through this GPIO cable. And in my setup, I've actually used this approach and mounted a Raspberry Pi 3B Plus on the back of my Elecro Crowvision 11-inch monitor. And that means that I can keep all of the power and video cables neatly out of the way in my monitor. Now, I've actually used this mounting method on my Replica Commodore 64, and if you're interested in building one of those, do have a link in the description down below. And what this means that I now have a growing number of retro computers, and these of course are all keyboards and case units that need a Raspberry Pi to work. But by mounting an IDC connector and then using a ribbon cable to come out from there, what this means is that I can now swap in and out my different computers. And just needing then, once I plug a new computer into my Raspberry Pi in the back of my monitor, I simply swap over the SD card and I instantly have then a different emulator running, and I can run my retro computer. Now, for me, I find that this works much better than having dedicated Raspberry Pis in each of the cases and then having to sort of swap over all the cables and so on to get something up and running. But again, there are two choices, and we'll look at both of those today, and it really is up to you how you decide to set up your system. So now that we've got the hardware sorted out, we need to have a think about how we're going to interface and build a circuit to get our keyboard connected to our Raspberry Pi. So the ZX Spectrum emulator, it just requires us to connect the keyboard membrane ribbon cables. Now, if you look at the membrane, there are two ribbon cables, one at each end of the keyboard, and these carry the row and column lines for the keyboard switch matrix. Now, these ribbon cables do need special push-fit connectors to mount them onto a circuit board, but they're actually very easy to find online. And again, I'll put some links to those on eBay and so on. Now, you can, if you want, solder flying leads directly onto the ribbon cables, but I personally would advise against this. I don't actually have a valid technical reason for advising against it, but it just doesn't seem like the right way to do it to me. Now, these lines are then just fed onto the GPIO pins of your Raspberry Pi so that it can drive the matrix. So we do need to fit some signal diodes onto the 8-way connector, and that then simply avoids, when you have multiple key presses, you can cause short circuits on the matrix because of the way it's wired up. So we do need these signal diodes then just to protect us against that. Now, in ZXBaremulator, we do also need some extra buttons that allow us to enter the menu and then select our tape files and so on, and also to switch between different models of the ZX Spectrum. So to do that, we need to fit an extra button. Now, this extra button then, when we press it, that will put the emulator into an alternate keyboard mode. And what that really means is once we're in the alternate keyboard mode, using the number keys, we can actually emulate pressing the function keys on our normal keyboard. And that's what it uses then to switch between sort of like the 48K Spectrum and the 128K Spectrum and so on. So we need this separate momentary push button. Now, all that momentary push button does is simply pull one of the GPIO lines low, and then the software picks that up and puts it into this alternate mode. Now, on my ZX Spectrum case, there is actually a small reset button on the left-hand side, and I'm going to use that. Now, obviously, if your case doesn't have one, or you're using a model which does, the 16 and 48K models don't have this reset switch, so you're going to need to use another push button and just simply mount it so that it is accessible through one of the cutouts in the back of the machine. So that gives us our final circuit that we need to build up to get this connected to our Raspberry Pi. Now, the circuit's actually pulled from an article in the Magpie magazine where they were connecting up a ZX Spectrum case to RetroPie. So please do have a look at that article, and again I'll put links to the free PDF download in the description down below. And it does of course give you some more information about how the project works and how the ZX Spectrum keyboard matrix is actually laid out. So before we commit to actually building the circuit board properly, it is worth doing some testing. So this will help us ensure that everything is working correctly, and we can do that on Breadboard. So as you can see on the screen at the moment, to get this up and running, I've created two small circuit boards to mount the ribbon cable connectors, and that then allows me to easily connect them onto my breadboard using some flying leads from these pin headers that I've soldered onto the board as well. So the breadboard will also then contain those 8 signal diodes to protect the circuit, and then from there we're just feeding all of the different signals directly into the GPIO connector, and I'm using this GPIO breakout board just to make that a little bit easier for me. For now, I'm just going to put in a separate push button which will activate that alternate keyboard, and again I'm just wiring that straight onto my GPIO expander board. Now once everything is built up, powering on the circuit should give you a fully working ZX Spectrum keyboard, but obviously that isn't always going to work first time. So if you do find that your circuit isn't working, there are a number of possible causes. So firstly, of course, do make sure you check through your wiring for wrong connections, and also make sure that the ribbon cables are securely seated into their connectors. You do need to make sure that they are the right way round. These connectors, the ribbon cable itself, the metal trace is only on one side of the ribbon cable, and that needs to be in the correct way round on these connectors. So the metal should be pressing against the little spring-loaded contacts, and that will then give them a good connection so that they will work. So do make sure you check those. Now, if you still find that you've got some keys not working, it might be that your keyboard membrane has a fault. So one of the common faults is that the traces on these ribbon cables do fracture, and that does break one of the signal lines. So the keyboard matrix itself is laid out as shown in this diagram. So if one of your membrane traces is not working, you're going to find that either a complete row or a complete column of these keys won't be responding. So if you do find that that is the case, then you will really need to replace that membrane. It's not something that you can easily fix yourself. Now, I found that with mine as well, and to be honest, the person who I bought the unit from did actually advise me that the membrane was probably broken. So I have made a video on how to change that membrane, so I'll put a link to that again in the description down below, so have a look at that if you find yourself in this position. But have a go through. Usually there are not that many faults, but if you do have any problems, as I say, do just simply, you will find that sort of replacing these, it's not too expensive, the parts for these. But eventually then, once you've got all of your issues sorted out, you should arrive at a working machine in your test area. So now that we've confirmed that we have all of the individual pieces of our project working, it's time to actually build up a more permanent circuit so that we can fit this actually inside the machine. So eventually I will take you through the process of designing and building your own PCB, but for now I'm just going to use a quick and easy method of prototyping my circuit, which if you're just building one off, this is perfectly good. It is a nice way of building your circuits. So of course there are quite a few different options for how you would put together a little sort of prototyping board, but the one that I prefer is using matrix board and then using wire wrapping wire to actually make connections which I can solder directly onto the circuit board then. Now, we will need at least 2 circuit boards. One of these is going to be then for each of the ribbon cables. So as I used in my prototyping board, these boards simply need to have the ribbon cable connector and then some means of running some flying cables with the signal lines out to our main board. Now, where you mount these then, if you look at a real Spectrum motherboard, you'll see the general location for these connectors, and these are mounted so that they allow the ribbon cables to naturally sit inside the case without any sort of very tight bends which would otherwise sort of damage them, and that's where those traces get fractured. So to mount mine, all I simply did here was I installed the membrane. I then put the connectors on the ends of the ribbon cables. I then mounted my keyboard top onto the base just so I could see what was going on. I then had a look at where the connectors naturally fell. I did then allow myself some slack, and then I just simply hot glued those boards into place on the base of the ZX Spectrum case. So once those are fitted in, the last circuit board that we need, this is where we have our two choices then. We can either fit a Raspberry Pi Zero, or we can build a little main board circuit board that will take the flying leads and then convert those into this 40-way IDC male ribbon cable connector. Now, if you are going to use a Raspberry Pi directly in the case, you're going to need to mount it inside that rear expansion slot, and you need to mount it so that you have access to the I/O ports. Now, your best bet is to either use very short PCB standoffs or to simply hot glue the Raspberry Pi in place. That expansion port cutout isn't very tall, so you might find that your PCB standoffs just push your Raspberry Pi up a bit too high to actually get the connectors plugged into the ports. Well, if you do that, then of course you can then plug the flying leads coming from both your alternate keyboard switch and the actual ribbon cable connections. If you use these sort of DuPont flying leads, you can just simply plug those then onto the pin headers of your GPIO port, and that would be the whole system all ready to go then. Now, as I said, I'm going to use a ribbon cable connection out to an external Raspberry Pi, so I needed to build a small circuit board to interface between the flying leads and this IDC connector. So to mount all of this into the expansion slot, I actually mounted the IDC connector on the bottom of my matrix board and then used PCB standoffs to mount the assembly into the expansion slot. Now, I did want to make sure that I didn't get the IDC connector butted right up against the base of the case, so I actually used a little unpopulated circuit board just as a bit of a spacer while I was mounting everything in place, and that really just made sure that my actual IDC connector was mounted neatly in the center of the vertical space in that expansion slot, and everything then just fitted in really nicely. The actual standoffs that I used were a little bit too short, probably 1 or 2 millimeters, so all I did there was I just put a slightly bigger blob of hot glue onto them, and then as I was sticking down my board, I just made sure that my IDC connector was in the correct place, and then just allowed the hot glue just to act as a bit of a spacer, as well as then cementing everything in place. And that gave me, actually, I was very pleased, that actually gave me a very neat rear port connection. So for me, all that was needed then was that I simply needed to connect my 40-way ribbon cable from my ZX Spectrum out to my Raspberry Pi, which of course, as I said, was mounted in the back of my little mini Elecro LCD monitor. So at this point, we should have everything built up, and we should really have a fully working Replica ZX Spectrum. So of course we do need to do some final testing just to make sure everything's up and running. So to test that all of the keys are working, your best bet is to power up the emulator. So we should then drop into the ZX Spectrum, and then we can just do a simple line of code just so that it lets us test all the keys. So we need to type in a rem statement. So if we type in 10 followed by rem, so the rem command is on the E key, so you should get a K cursor and then just press the E key, and that will bring up the keyword rem. Now don't press return after that, but what that lets us do then, the rem statement is a code remark. So after that, we can just simply type whatever we want in. So if you now start typing on your keyboard, you should find that all the key presses then will bring up the correct letters. Now, when I first tested mine, I did actually find that I had made a mistake. My number 4 and my 5 keys were swapped around, and when I did some more testing, I found that the R, T, F, G, and H, J, and those sort of connections were all swapped round. So again, you can identify what the problem is by looking at the keyboard matrix layout. And if you see here, the 2 lines which were swapped round are on the KB1 connector, which is the little 5-line connector. And for me, you can see here that my lines 4 and 5 were actually swapped around, so that when I pressed my number 4 key, I actually got it registering as a number 5 key. So we'll get, of course, when I then went back inside the case, I could see quite quickly then that all I've done is my flying leads that I was plugging into my ribbon cable connector board, I actually had twisted 2 of the wires round so that the last 2 wires were swapped over. So just simply fixing that then, for me, fixed that problem. But again, because we have done the testing on our breadboard, we should know that we're not down to bits and pieces not working. It's just going to be some sort of wiring issue that we've got. So you should at this point have a completely working Replica ZX Spectrum sitting in front of you, ready to go. Now, moving on from here, so this, as I said, the circuits we built in here were a bit rough and ready, so we could make the whole installation a bit better by making a custom PCB that would hold everything together a bit more securely and allow us to mount it properly into the case. Now, I will go through that at some point in the future. I do want to sort of have a look at actually making our own PCBs at home, both sort of through-hole PCBs and surface mount technologies. But I will have to leave that then for another video. Now, I hope you've enjoyed this video. Please do have a go at building your own one. These really do bring the whole experience of using these machines back to life again. If you have enjoyed this, please do click the like button and make sure that you subscribe to my channel so that you don't miss any of the upcoming episodes. I look forward to seeing you again in another video very soon. So, bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.